Okay, we're going to be doing isotopes and mass spectroscopy. Okay, so the relative atomic mass is defined as the weighted average of the mass of all the atoms in a normal isotopic sample of the element. So, essentially, different numbers of neutrons in an atom are considered different isotopes. So, if we take, for example, carbon, right, we have carbon-12, and we denote that with a hyphen. That's 6 protons and 6 neutrons, because remember, electrons do not count towards the mass of an atom. So now we have 6 protons and 6 neutrons, but take the isotope of carbon, one of them, carbon-14, then we have still 6 protons, right, because changing the proton amount changes the element. So then we have 6 protons equals 14 total. So then we have plus X neutrons, which we can just do a little simple arithmetic, and we get minus 6 both sides, and then X equals 8. So now we know that we have 8 neutrons, right? So the average atomic mass is defined as the weighted average of all of an element's naturally occurring isotopes, right? So we're not just shooting neutrons into a nitrogen atom and just seeing how many it can take before it explodes, basically, or corrupts itself. We're just doing what's found on Earth. So the decimal number on the periodic table is the average atomic mass, which is AAM, and that is measured in atomic mass units. So two different, pretty similar abbreviations. Okay, so we have isotopes and mass spectroscopy. So the average atomic mass equals the sigma, which is math terms for the summation, or all of them added together, of the percent of each isotope times the atomic mass of each isotope divided by 100. And the shorthand way to do this is to just move the decimal. When we get the percent, just move the decimal 2 places. So say we have 80%. That'll equal 0.8 times X AMU for whatever the mass is. Okay, so let's do a problem. Let's see how this works out. Okay, so neon has 3 isotopes, 22, 21, and 20 AMU, so we're going to write this. Neon 20, neon 21, and neon 22. Okay, and they have percent abundances of 8.01%, 1.99%, and 90% respectively. Okay, so let's just do some quick calculations. So we're going to do 22, do a little parentheses, and we're going to multiply that by the percent. So we're going to get a percent of 0.0801. We're going to add that to the next one, so we get 21, right, because that was our second isotope. We're going to multiply that by, move this decimal 1, 2, so we get times 0.0199, right? And then, of course, neon 22 is the most abundant, and we get 22 times 0.9, right? Because it's 90% respectively. And we're just going to put that into our calculator, and we get an average atomic mass equal to 20.1801, and that's measured in atomic mass units, or AMU for short.